Hello. Right, here we go. Algebra. I think this was lesson 6. Right, all about algebra today. Okay, so algebra uses letters such as X and Y and Z, etc. And it uses two combinations of letters as well. Now, the letter, why we use a letter, right, is because it's a variable. It's a variable. It can change, the value can change. If, for example, we have 2x and x is equal to 10, then this means 2 times 10, yeah, which is 20. But if x is equal to 20, then 2x becomes 2 times 20, which is 20, which is 40. Yeah. So the value of a letter can change. It's a variable, and the reason why we can use the same formula, as it were, the 2x and the 2x, and we can just do the same thing, but when the value of x changes, we get a different result. Okay, so now we'll see algebra come up in all sorts of things, as in finding the area of a circle, which is pi r squared, where r is the radius, which will come up. This is pi, this is the radius, and the radius of the circle is that r. So you can see that you can use algebra with lots of variables, the r being one of them, depending on the size of the circle. You can use the same formula to work out the area. Doesn't matter what the radius is. Pi, by the way, this Greek letter pi, is the relationship between the length of the diameter, that one, diameter all the way across going through the middle, and the length of the circumference all the way around. It's about 3.14. Yeah. Right. Okay. So now the first thing we're going to do is collecting like terms. And what is a term, first of all? 2x plus 3y plus 4z plus 10 minus 10, yeah? These are terms. There's a term, there's a term, there's a term, there's a term. It's a component within an expression or a formula. The pi r squared would be a term because it's all together. But this is what we're looking for. Now, when we collect like terms, what we're doing is we're putting everything that is the same together. For example, if there were no letters and we just had 2 plus 3 plus 4, we just add them all together to get 7, 8, 9. So it's like you've got 2 counters, 3 counters, and 4 counters spread out all over the table, and you're just gathering them up together to be one big pile of 9 counters. Now, if the counters are different colours, say you've got red ones, blue ones, green ones, and they're all muddled up in a big pile, then you can separate them out into the different counters, but you can only put the same colour with each other. And this is like this. So we've got 2x plus 1y plus 3x plus 4y. Now, collecting like terms means looking through all the different terms to see which ones are exactly the same as each other. So here we've got some x's, so we'll add the x's together to give 5 of them. And you've got the y's, so we've got 1y there and 4y's there, so that would be 5y. So collecting terms, that's all you're doing. So you can have numbers in them as well. You can have 2x minus 4 plus 5x plus 6, and you collect the numbers together and the x's. So 2x and 5x is 7x, and minus 4 and plus 6 comes up as plus 2. Now it's important to remember, let's find something where I can colour it in for you. It's important to remember that the individual term does include the sign that comes immediately before you, because this determines whether it's positive or negative. Now the very first one, would have a plus in front of it here, but because it's at the beginning we don't bother draw it. So we've got 1, 2, 3, 4 terms, and this is the negative one, and when we add it together with the plus 6, it's just like 6 take away 4. It leaves us with plus 2. Let's go back to this pen. Right, okay, so and it doesn't actually matter what these terms are. Don't be fazed by crazy things. If we have 4 plus square root of 3 minus 1 plus 3 square root of 3. Now, this term here, so let's colour in the terms. So we've got a term here, which is plus 4, and we've got one here, which is square root 3, then a minus, and then 3 times the square root of 3. So don't separate these. Don't go minus 1 plus 3. You can't do that because the 3 is connected to the square root of 3. And this is just telling us that we've got 3 of them. So to collect like terms when you have something like this, you can do the numbers. So you've got plus 4 minus 1, which is 3. And then you've got 1 square root of 3 and 3 lots of square root of 3, which will make a total of 4 square root of 3. Right, see what else we did. What else did we do? Now, when we're collecting like terms, must remember that it must be exactly the same. Yeah, you see we've got some x's over here on the left for 2x, and we've got some x's on the right. Let's just minimize that so we're still going. Yeah, x is on the right, but these are x squareds. So when you're collecting like terms, you can only put these square things together. You can't mix them up with a 2x. So this will come out as 2x plus 3y plus 4x squared minus 2x squared will be plus 2x squared. So be careful when you're collecting like terms. Right, now let's do apply algebra to some shapes. Now here's supposedly a square, yeah, and when we're working out the area of the square, say that's 4 centimeters, all the sides of the square are exactly the same, and when we work out the area we would do 4 times 4 equals 16 centimeters square, yeah, because that's the measurement of area square. Now if we have a square that has got x, then all the sides are x. So the area of this one is x times x, which equals, now it's not 2x because that would be adding them together. Now we're multiplying them, so that would be x squared. So when you multiply things together, yeah, so that's x and that's y. So you would have the area would be equal to x times y. Now, if you have something like this, and there's y, and there's 3y, meaning that the top is 3 times as long as the bottom, the side rather, so the area equals 3y times y. Now, still going to be 3, but the y times the y gives you 3y squared. Let's have a look and see what other examples I had. Okay, so then we split this up into this sort of thing, and we had P and 3P and Q and R. So the area of all these individual parts, So this one is P times Q. This one here is P times R. This one, put some little dots in there, that one is going to be 3P times Q. And this one is going to be 3P times R. Now, what's the whole lot? The whole lot would be all this times all that. So this is Q plus R. You've got to add them together. Now put a bracket around there to make it look tidy, times the top. Now 3p and p, we can add them together because they're the same. We're collecting like terms. So that makes 4p on the top. Yeah. So we could lose that multiplication sign and just put QR. Don't put QR. My brain was ahead of me there. I was thinking of the other one. Yeah. Q plus R 4p. Yeah. Now we're going to look at expanding brackets in a minute. But first of all, we'll go through the other areas there, or the other shapes of areas. So we can have a triangle. Now the area, it doesn't matter whether it's a right angled triangle or any other kind of triangle. The area of a triangle equals half times the base times the height. Yeah, no multiplications, it's all multiplications. So now the one thing to remember with the height is it has to be the vertical height. Yeah. So if we have a triangle with I don't know, let's say that's 4x and say the height is 3x. So the area equals half times the base times the height, which equals half times the base, which is 4x, times the height, which is 3x. Now, a half times 4x is 2x, and times 3, so 2 times 3x, so you go 2 times 3 is 6, and x times x is x squared. If you did it the other way, from half times 4x times 3x, and you multiplied the xy bits together, so you've got 4 3s are 12, x times x is x squared times a half, and a half times 12x squared is going to be 6x squared again. So it's exactly the same. Exactly the same, using algebra to find shapes. Now this shape here is a trapezium. And there's a formula for working out the area of a trapezium. So I'll call that A, I'll call that B, and the vertical height again is this, H. So the formula is A plus B. So you add the top and the bottom together, and to find the average length between the two, you divide it by 2. Just like if you have 10 plus 12 divided by 2, you'd have 22 divided by 2 and equal to 11. So halfway between 10 and 12 is 11. So that's what we're doing there, but we don't know. And then we don't know what the lengths are with A and B times the height. So that's the formula for the area of a trapezium. So let's put some letters in there, I suppose. Put some letters in there. So we'll say that keep the blue, yeah? We'll say here. Right. And the reason why it's a trapezium is this and this are parallel to each other. So we'll call that 5x, and we'll call that 7x, and we'll call the height 2x. Yeah, not to scale, of course. Right. So we've got A plus B divided by 2 times the height. A is the top, so we got 5x plus 7x divided by 2 times 2x. So 5 and 7x is 12x divided by 2 times 2x. So that comes 6x, times 2x, which equals, well, hang on, let's go back, which equals 12x squared. Oh, right. So we did things when we're multiplying. So this, we need to remember to multiply with negatives. So when we just write a 3, it's a positive. So 3 times 4 equals 12. 3 times minus 4 equals minus 12. Minus 3 times 4 equals minus 12. And minus 3 times minus 4 equals plus 12. So when the signs are the same, there, you end up with a positive answer. Positive. When they are different, you end up with a negative answer. And this rule applies to division as well. It's exactly the same. So if you have 12 divided by 3, you end up with a positive because they're the same. If you have 12 divided by minus 3, you get minus 4. If you have 12 minus 12 divided by 3, you get minus 4. And minus 12 divided by minus 3, you get positive 4. So when they're the same, you get a positive result. When they're different, you get a negative result. And we did a little sort of sidetrack when we go back to an earlier bit where we were working with powers, and this will hopefully explain adding and subtracting. Add and subtract, come down, add and subtract with negatives. Probably the best way to do this, working with powers, with powers. So when we have like x to the 4 times x to the 4, when we work that out, we just add. So this becomes x to the 8. So if we have x to the 4 times x to the minus 2, we are still adding, but when you add 4, add minus 2, you end up with 2. It's just like 4 take away 2, but it's not. It's not a subtraction, it's an addition. 4 add minus 2, 4 and minus 2. And if you have x minus 4 times x minus 2, we add these two, minus 4 add minus 2 will equal minus 6. So yeah, we've got a bit of a different sort of set of things to think about when we're adding negative numbers, and the same goes when we're subtracting. So when we're dividing, we subtract the indices. So 8 subtract 3 is x to the 5. Now when we have this minus 3, we're going to subtract, and this in effect means 8 subtract minus 3. Now when we have two negatives together like that, it has the same effect as 8 plus 3. Yeah. So when we have 8 subtract minus 3, it comes out as 11. Yeah. Two minuses make a positive. We can do a different one there. So if we have x minus 4 divide by x minus 5, what we've got here is minus 4 subtract minus 5. Now, we start with minus 4 and we in effect add 5. So we're back up to plus 1. And when we have x to the power of 1, we can just write 1. Okay, so then what do we do? Then what do? We tried to make things a bit more crazy, didn't we? Let's have a look. Oh, what we did was, the last bit of this lesson was we expand brackets. Now we nearly did that earlier on, but I stopped in my tracks. Where were we when we had there? We had the opportunity there to expand the brackets, but we didn't. So we'll find out how to do that now. If I can get this to come down and then go back up. Getting seasick going up and down like this. Right, come down and down. Right, expand brackets. Now, when you have numbers 2 plus 3, 4. Yeah, this means 4 times all of that stuff inside the brackets. So when you've got numbers, you just add the numbers together. 2 and 3 make 5, and then you multiply it by the 4, which is 20. All nice and easy, yes? But if you have 4x plus y, you can't add the x and the y together because it is already written x plus y. So there must be another way to do it, and there is. So let's have a look at this. 4, 2 plus 3, go back to that original one. Now if I multiply everything inside the bracket in turn by what's outside the bracket, see what happens. 4 times 2 is 8, and 4 times 3 is 12. Look, 8 plus 12 equals 20. So there is a way around it without actually adding the two things inside the brackets. And this is what we're going to do with the algebra. You go 4 times x is 4x, and 4 times y is 4y. Yeah. And of course, we can have a letter outside the bracket. So x times x is x squared, and x times y is xy. That's just xy. No minuses, yeah, no minuses. It doesn't matter how complicated this can get. You can get 4x, 3x plus 2y. Right. So now we're going to multiply that by that. So you can break this down further by doing the numbers bits and then the letters bit. So 4 times 3 is 12. X times x is x squared. Now, 4 times 2 is a plus sign there, look. 4 times 2 is 8, and x times y is xy. So it doesn't really matter how complicated it gets, just take things in turn. So let's do 3x squared, x squared plus xy. Now, multiply that by that. So we can't do the 3 with anything, so we just drop the 3 down there. Now we've got x squared times x squared. Remember when we multiply things with indices and they're the same, we add the indices. So this becomes x to the power of 4. Now we'll add, and we've got 3 times, we just put the 3, there's no numbers there. X squared times x, yeah, that would be a 1 there, x to the power of 1. So we've got 2, and the invisible 1 will be x to the 3, and There's nothing to multiply with y, so we just stick that in there as we did with the 3 from there. And that's how to expand brackets. Or should we do a minus number just to 5x minus x plus y. Okay, so that times that. There's no numbers inside, so we just read the 5. Now x times minus x. Now that would be minus x squared. That's going to be complicated. X times x is minus x squared. So 5 minus x squared. So this actually means 5 times minus x squared. Oh, never thought of that one before. 5x times y is 5x y. Now, can we get rid of this bracket? Now we've got a positive 5 and a negative x. So if we multiply those two together, it will be minus 5x squared. Yeah? So it may have been that you've done 5x times minus x to get minus 5x. You could do that bit straight away without the awkward bit in the middle. Minus 5xy and 5xy. Okay, that, I'm afraid, is the end of that thing about algebra.